Minasan konnichiwa, Zamurai Engineer desu. In this video, we will continue discussion on webinar series of NFPA 101 Life Safety Code. We are currently in this module 2.4 PBD Building Blocks. So I'm your professor, Dr. Zantua. I'm a civil engineer, electrical engineer, industrial engineer, and mechanical engineer. I am an alumni of Polytechnic University, Japan, being a Japanese government scholar. Let us start with our discussion by this page. The Life Safety Code addresses specific requirements on safety to life, mission continuity, and property protection in both new construction and existing buildings. We have part 1, and we are currently discussing Code Core Chapters. We are having on our monitors the listing of the core chapters. We are already through with several discussion. We are now on the fourth one, which is PBD building blocks. So this is module 2.4. What is PBD stands for? It is performance-based design. PBD, performance-based design. So chapter 5 is titled performance-based option. So it is an option, this design methodology is an option that could be used whenever there's a difficulty in addressing the minimum requirements set up by the code for the specific application. So performance-based option have 8 sections. So we have again general requirements as the start of the section, and 5.2 performance criteria. Now, there are criteria involved. This section is not an option to arbitrarily circumvent the provision of the code. Okay, so it is not the purpose. This is to allow alternative design method. Okay, and actually, in my point of view, in my opinion, this is the engineering type of design. Performance-based design is the engineering type of problem solving, gathering the requirements of the problem, setting up the assumption by inspecting and observing the field, and then solving the problem and implementing the problem. So this is the engineering that we learn. Okay? In the prescriptive type, actually, it's not the real engineering type of problem solving, because you just have to what? Follow the code, read the code, follow the code. It is. So here in the performance base, the designer decides on the assumption to be made. Okay? And what are the relevant threshold? There are criteria, but there are threshold that the designer could flexibly decide on. Okay? So for example, I need this material, but I will use this material because of these reasons. One. There are several reasons. Okay? So In prescriptive, you are just listed, these following materials are allowed to be used. So you just have to click on that. Okay? What about if the material is your way of solving the problem? Okay? And it is not yet known to the area of your expertise. Okay, so you have to. This is now what the real engineering that we practice, that we learn from school. Okay, so prescriptive code, the engineering in the prescriptive code are those who made the code, who made the proposal, who made the, they are prescription, just like a doctor. The doctor prescribes, and then uh, the uh, the professional follow. Okay, so which one is the what? Which one is the engineer? Those who prescribe, not those who follow. Those who follow is just a user. That's why the code even use the word user. The code is not using the word fire protection professional, but it is user. Right? Just user. You just have to follow what is written in the code. Is following that engineering? That is not. Following the code did not require an engineering background. It could be a technician that could follow the code. It could be a technologist that would follow. Technologist and technician could follow the code. They are also involved in fire protection professional, but they are not engineers. So prescriptive code is really just using the prescription. You just have to follow the code. Are you an engineer? Okay, so it is debatable. There would be somebody who would not agree. There may be more who will disagree, but somebody who could understand the field and could understand the instruction would be able to follow prescriptive. But you need an engineering degree to be able to make a performance-based requirement. This is an engineering problem solving. There are engineering problem procedure cycle that have to be uh, followed. Okay? So this is the engineering type of solution. This is an engineering type of solution. You are what? If you are the designer, you are actually proposing a specific solution. If you are being told to follow prescription, those experts who prescribe, they are the one proposing the solution. You are just following the solution. And realize, make it into a reality. Okay? So, the engineering part there is making that idea into reality. That is also an engineering, but that is not a very broad area of engineering. A broad area of engineering is the problem solving, wherein the engineer solves the practical problem. And that is the performance-based option. So you are just what? Given the criteria and what? 5.3 retained prescriptive requirement. You can have a prescriptive requirement functions there, but more or less you are what? Doing it on your own as a designer. Okay? And number 4, design specifications and other conditions. Okay? So, listing of specs, another, not just the criteria, but the specification. In engineering learning, in engineering education, this is what we call given. So, problem, given, required. What are they required? The design, result, your proposal, your solution. Those are what you're going to do. Okay? 5.5, design fire scenarios. You will what? You will show scenarios in order to convince the others that your proposal will work. Okay? Because it's not yet utilized. For example, it is the first time that it is to be used. So you are going to design fire scenarios. So meaning to say, if your performance-based option for a particular small area of occupation becomes suddenly popular and become known to professional and used by them, later on it will become standard. Later on it will become a standard, and you is the main proponent of that. You. That's why this is the start of being prescriptive. It starts with the first, what we call, first instance. You are the inventor. You are the concept designer. You engineer the system yourself at first, wherein nobody else yet have been able to take a look and propose. So you are the first one. So it could be. So it could also be you are the 100th one, because being a standard means more than 100 application. Your system becomes so popular and so useful that thousands. So if there are thousands of professionals that is using your system, you are now the main proponent of an standard. It will become a standard. 100 professional, I think, is not yet on the level of standard. So it will become a standard if there are thousands, or tens of thousands, right? Those type of meaning, it, because it is being utilized on that magnitude, it means it is working effectively. They will not use your system if it is not working. If there are so many failures, nobody will use it, right? So later on, it would become a standard and become a prescriptive type of provision. So first, you have to do it whenever you come across with a particular application that is not yet defined in a standard, or the current situation is not feasible to use the prescription. For example, even the doctors that prescribe drugs, if you go to the pharmacy and the pharmacy do not have that particular drug, you will be given an option by the pharmacist. Would you like the generic type? Okay. Would you like this? So you will be given an option. Right? So this is the richness of the code. If you are just following the prescriptive type, well and good. There's no problem. But if you are on the performance based, you are real engineer. Okay? In my opinion. At least in my opinion. Okay? However, in the Philippines, we almost always forget about that there is a performance-based option. In Japan, where I learned mechanical engineering, most of the code is performance-based. Okay? That's all for our discussion of performance-based code requirements. Again, we would like to ask your help to like, share, and subscribe our small channel. We are very small. We would like to help more and more students. We'd like to help more and more uh, people that would be helped by our free tutorial in many ways. We would like to ask your rest of fund, our advocacy. You may post an ad for minimum sponsorship. If you see the logo below my picture, that is where your ad can be posted. So please contact us. We have contact details shown in this page. Again, this is Dr. AP, preaching engineering for nation building.